Number 2 is asking us to create a graph to represent the information in our table. Be sure to label our axes. So the very first thing you should always do when you're creating a graph is label your axes. And so when we talk about labeling our axes, our x-axis here, this is our independent variable, and our y-axis is our dependent variable. So from our table, our independent variable we said was our number of days. So let's label this as our number of days. And we represented that with D. And then our vertical axis, or our dependent variable, we said was going to be the number of people. So let's label that as number of people. And we said number of people was our P of D. And then if we take a look, and you can scroll back or turn over and look at question number 1 again, that has our table, the information that we need. If you notice that our numbers go up really, really high, all the way up to 8 million. So on this small area that we have here, I think it's going to be hard to get every single point from our table on our graph. So I think if we just get a few points on here, we should get an idea of what our graph will look like when we graph that information. So our number of days just goes up to 8, so we can very easily go up by ones on our D axis. So let's label that. We have 1, 2, 3, 4, 5, 6, 7, and we can continue that on, but we get the idea that we're going up by ones. On our vertical axis, I think to get some of the first few points on there, if we want to get up to at least that 800, we can go up by 100 each time. So let's go up by 100, and this is not something that you have to do. You can find your own number that you want to use to go up by each time, and your graphs are going to vary depending on what numbers you choose for your scale. So I'm going to go ahead and go with 100, 200, 300, 500, 600, 700, 800. And label that so we know that we're going up by 100 each time. And then if we plot a few of our points, which we'll be able to do, our first point coming from our table is that point 1, 8. So I'm going to plot the point 1, 8. And if you notice on our graph, if I want to go to 1 and go up to 8, my very first intersection point is 100. So 8 is going to be really low and much closer to 0 than it is closer to 100. So when I plot that point, I'm just approximating since I don't have an exact intersection here. So 1, 8, I'm going to say is going to be really, really close down here to 0. Then my next point is 2 and then 80. So again, if I'm thinking about my 2 and I need to get to 80, again, it's going to be under this 100. But if I think about it, halfway through is 50. So I want to be between 50 and 100. I want to be closer to the 100 than I want to be to the 0, and I want to be above that halfway mark. So I'm going to put my point right around here. So 2 and then 80 is going to be about right here. And then I jump to 3 and 800, and 800 is all the way up here. So I'm going to do that point 3, 800, which is right here. And then I can kind of see what's happening with my graph. It looks like I'm coming here, I'm going up kind of fast, and then I go up really, really fast as I come here. So you can see that that graph is starting to rise very, very quickly. It is not a straight line anymore. So in letter A over here, is your graph a straight line? It's not. I can't connect these 3 points in a straight line. So I'm going to say no here. This is actually what we call an exponential curve, just to keep that in mind. So our geometric sequences, which is when we multiply each time, we talked about that in question 1. Our geometric sequences are going to create these exponential curves, where our arithmetic sequences create straight lines.